Hi, this is Mr. Merrill, and this is problems 15 and 16 on the homework. So 15 asks for the force of this child pulling here, and 16 is asking for, it words it in a weird way. It says, what is the force exerted by the on the sled by the hill? Well, that's just the normal force. So this is essentially asking for Fn, and this is essentially asking for, in my diagram, what's called F pull. So, a couple things that I thought might be the issue here is, if we look at our force diagram, notice that I don't have any frictional forces. It's just the pull from the child, the normal force, and the force of gravity. And the reason I don't have any friction forces is because it says it's frictionless. The other issue is, remember, if this angle, this kind of ramp angle or tilt angle is 25 degrees, and this internal angle here, opposite side between the negative y-axis and the gravitational vector, is also 25 degrees. So another issue you might see is, notice down here when I listed the components, I do not put mg. I just say the magnitude of the force of gravity, because the magnitude of the force of gravity is the weight. So if it tells me the weight is 56 newtons, that's what it's telling me. So obviously you could find the mass from the 56 newtons and then plug the mass into mg, but you're going to end up getting 56 newtons anyway. So basically, if it gives you the mass, put mg. If it doesn't give you the mass, it just gives you the weight, put this. No need to substitute it. Anyway, so this is our initial setup, and then you can see over on the right side there, I've gone and made my two equations from this initial setup. This is from summing the x components, and this is from summing the y components. Just make sure that you have these negative signs here. That's pretty easy to forget. And now the problem's rather simple, right? Because if we want to find F pole, it only shows up right here. One step of algebra to rearrange. We get this. If we want to find the normal force, one step of algebra, we get this. So fairly easy to calculate, and you can actually see, it's nice because you look back in the equations, and this is where the congruency marks really help make sense of this. It says the pole equals the opposite component of this gravitational force, and you can see that perfectly in our diagram here. And this is essentially saying the other set of congruency. So it's really nice when our equations line up so nicely with what we see in the force diagram. Okay, so you can just go ahead and plug the numbers in there and get your answers. But once you have this initial setup, it's a really easy problem because the algebra is so straightforward. Okay, so if you have any questions, just email me.